motion. So this is the first example of that type. You've got a particle moving along a straight line. At time t seconds, its displacement x from a fixed point O is such that d2x dt squared is equal to minus 4x. So let's write it down. This is the differential equation. What I'm going to do is use the notation x for the acceleration. Okay, x2 dots for acceleration. So x double dot is equal to minus 4x, which clearly you will recognize it better as this equation. The auxiliary equation is going to be m squared plus 4, which gives us m is equal to plus or minus 2i. Therefore, we are looking for the expression for the displacement, so we're looking for x, so that's why we are solving it. So there's no real part, so no e, and it's going to be a sine 2t plus b cos 2t. We've got some conditions here. T is equal to 0 and x is equal to 0. And we also have velocity. So let's substitute t equals 0 and x equals 0 into the solution to obtain one of the relationships between that sine 0 is 0 plus b cos 0 is 1. That gives me b is equal to 0. Okay. So x is now going to be equal to a sine 2t. Now we're going to use the fact that velocity is equal to 4. So that means x dot is equal to 4 at the same time. Let me just go back very quickly. I'm not going to be re-recording it. I have made a mistake. So x is actually equal to 1, judging by this. So b is not going to be 0, which is good actually. So that's 1, which gives us 1 here. So b is equal to 1. So we have not got rid of b, which is fine. Okay, so we're going to use the second condition that at the same time the velocity is equal to 4, so we differentiate the solution. So this is 2a cos 2t minus 2 sine 2t. Let's substitute the x dot equal to 4 and t equal to 0. So 2a cos 2t is 1 because cos 0 is 1 and minus 0. So a is equal to 2. So the solution to this differential equation and therefore the expression for the displacement is 2 sine 2t plus cos 2t. Good. Okay, so now we're going to do part B, which says, let me just read it here. It says, hence determine the maximum displacement of the particle from O. So the maximum displacement is, to do that, you really want to find the maximum of this expression. So you're going to use r sine 2t plus alpha method. So you're going to change it into r sine 2t plus alpha. Now, in order to answer this question, you don't really need to go through the whole process of finding alpha. You just need r, because r is the maximum displacement, r is the amplitude. So as far as I'm concerned, r is equal to 2 squared plus 1 squared. So the coefficient of sine 2t and cos 2t, which is root 5. And that is the answer to that. So this is x max, if you like. But in case you want to find out when this maximum going to happen at what time, you really want to find what alpha is. So using sine, expanding this, r sine 2t cos alpha plus r cos 2t sine alpha, and combining this to the top expression, I could see that r cos alpha is equal to 1, because these two will match. Sorry, sine. No, it's this one here. So r cos alpha is equal to 2, and here r sine alpha is equal to 1. Because we know r, you don't really need both of these, or you could use tan method if you prefer, which I'm going to use. So tan alpha is going to be 1 over 2. Give me alpha equals to 0.4636. So in case you need it, there you go. But the maximum displacement is root 5, and we've answered the question already without going on. You didn't need to carry on there. The book does though, so I've done it. Okay, so that means we can move on to example 6. So in this video, I'll go through all the examples now that lead up to exercise 8b, which means there's example 6, and that's the only example left. Okay, so here we've got a particle P which is attached to the ends of two identical elastic springs. The free ends of the springs are attached to 2 points A and B. The point C lies between A and B in such that A, or it should be ACB, is a straight line, and AC is not equal to BC. Okay, so imagine there's your point A, maybe C will be somewhere here, and B is somewhere here. So these are those springs there. So two different springs, which you want, if you want to draw it, you could draw it like that. You probably know it from other topics that you studied in physics. And so there's one and maybe another one here. Anyway, so the particle is held and then released from rest. At time t seconds, the displacement of the particle from C is x and the velocity is v. The subsequent motion can be described by the differential equation x double dot is equal to minus 25x. So question A, describe the motion of the particle. Just by seeing x double dot being equal to a negative multiple of x is enough for us to confidently write simple harmonic motion. If you want to write it in 4 words, you can do it. And then they are asking us to solve the differential equation to find x in terms of t. So we'll do exactly the same as in the example before. So rearrange it first. And the auxiliary equation is m squared plus 25 equals 0, giving us m plus minus 5i. We're going to write the general solution, which is x equals, over here it's going to be a cos 5t and b sine 5t. And that's the general solution, but obviously to find the answer, full answer that they are asking you to find, you need to use these results. So x is equal to 0.4 and x dash is going to be equal to 0. We'll use that when we differentiate it. At the moment we'll use x is 0.4 and at the time when t is equal to 0. Okay, so let's pop it in. We've got 0.4 here, and we've got a times cos 0, which is 1, plus 0. So that gives me a equals to 0.4 or 2/5. Okay, so now we're going to, I'm not going to replace a with 0.4, just leave it like that, but you may want to do it straight away. But it's going to be minus 5. A sine 2t, 5t, sorry, if you differentiate x, plus 5b cos 5t. Okay, let's put all the other numbers in. So the velocity is 0, and then we've got minus 5a times 0 because t is equal to 0 as well over here, and then you've got plus 5b times 1. Okay, so b is going to be equal to 0 because 5b is 0. So the actual solution, we will not have the other part. A was equal to 0.4 cos 5t. Perfect. Okay, so let's just have a glance at the rest of the question. It says, state the period of the motion and calculate the maximum speed of p. Okay. So the period of the motion, if it was just cos t, it would have been 2 pi. So the period is the time it takes for one of the revolutions, one oscillations to happen. So normally it's 2 pi, but because it's multiplied by 5, the period is going to be much quicker because you're by 5, so you need to divide it by 5. Okay, to find the maximum velocity, we need to differentiate it. So this is going to be minus 5 times 0.4, which is 2 sine 5t. They are asking us for maximum speed actually, so it's this number over here. So maximum speed equals to 2. There you go. So now you'll be able to have a go at exercise 8b.